Yeah, sure. So we're this test is about parabolas, and so we have um, standard form and vertex form. Perfect. What the next two people typed up are the two forms, and I understand that you guys are asking questions, but so we have. Oh, let's see. Let's like divide the screen. So we have standard form, and then we have vertex form. Standard form is the one that does not have parentheses. It's y equals ax squared plus bx plus c. And then vertex form does have parentheses. It's y equals a parentheses x minus h squared plus k. I do want to point out that the letters are different with the exception of the letter A. The letter A in both equations is the same. Letter A, the same like concepts for the letter A. And so the letter A for both problems, when A is positive, that means it opens up and has a minimum. And for your range, you will write y is greater than or equal to. When A is negative, it opens down and has a maximum. Excuse me, hold on. Oh my goodness, I'm sorry. And then for your range, you would write y is less than or equal to. So that's what the letter A does. If it's in standard form, you'll need to calculate your axis of symmetry. And the formula for that is x equals negative b over 2a. And then once you know your axis of symmetry, then you will plug your x from the axis of symmetry back into the original equation. And then that will give you your y for your vertex. So whatever number you get from here, that's also going to go in your vertex. So there's a lot of math required for standard form. After you've found your vertex, this number, the y number from your vertex, that's also called, oh, I don't know if you guys can see that. That's pretty light. Let me see if I can make that darker. That's called the extreme. So the y number from the vertex is called the extreme, and then the y number from the vertex is also the number that you're going to put for your range. On oh my goodness, sorry. On standard form, you can find your y-intercept pretty easy. It's always just going to be the c from the equation. And to find your x-intercepts, you can look at the graph, or sometimes you'll need to use the quadratic formula. The quadratic formula, if you don't remember from last chapter, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that would be to find the x-intercepts when they're not nice, pretty numbers, when they're not like whole numbers. Honestly, like if you love the quadratic formula, you could do the quadratic formula anytime it's in standard form to find your x-intercepts if you really wanted to. It's a lot of extra work that's not necessary, but you could. I think that's all of the things that you need to know for standard form. And so for vertex form, you actually start with the vertex. And the vertex is the h and the k from the equation. So you don't have to do any work. You don't have to do any math. You're just pulling numbers out of the problem. Okay, so the letter h goes here and the letter k goes there. For your letter h, you have to do the opposite sign. So if you look in the original equation, it's subtracting h. So that means like I'm looking for the number that's being subtracted. And so if it says x minus 3, I would write a positive 3 because that's the number that's being subtracted. For the k, since the k is being added, you just take the number. And then from there, you can find your axis of symmetry very easily. It's just this number from your vertex. So you actually go a little bit backwards, and when it's in vertex form, you find your vertex first, and then you find your axis of symmetry. Just like in standard form, your y value from your vertex is also known as the extreme. And the y value from the vertex also goes in your range. So it goes in several different places. As far as your intercepts are concerned for vertex form, you really just have to look at the graph. If it doesn't fit on the graph, you can always make the other letter a number 0. So when it's the y-intercept, you would make x 0 and then solve. And if it's the x-intercept, you would make y 0 and solve. But if you can get it by looking at the graph, that's probably the best case scenario. So I think these are all the formulas and things that you need to know for tomorrow's test. And then we can definitely run through, yeah, so I'm seeing that you guys want to see like how to do, we had that like list of like 9 questions. So we can totally do a vertex form and a standard form. Do you guys have one in particular that you want to see, or can I just take one off of like the quiz? Okay, yeah, we can do that one. Let me see if I have, there was this flow chart that some of us used. Let me see if I can find this flow chart just because it has a graph on it already and it's got the list of all the questions so we can make sure we answered all of them. So I'm going to see if I have access to that. Let's see what this one is. That's not the right one. Hold on, let me see if I can find the right one. What are we in chapter 4? Let's see if this is the right one. Nope. I'm going to try one more time. If I can't find it, we'll move on. All right, I think I'm over it. Let me see if I can just find anything that has a graph. I'm not going to be able to even find that, am I? No, this. Oh, we'll just use this one. It'll be fine. Okay. This is my Algebra 1 flowchart, and it's not the same questions. You guys have a couple more questions, so there's some stuff that's happening in Algebra 2 that didn't happen in Algebra 1. So we'll just add to it. So the problem that we're looking at is y equals x squared plus 8x minus 9. And then there's a list of 8 questions. So question number 1 is, does it open up or down? And so this one is in standard form. And in standard form, we have an A and a B and a C. And so my A is the number in front of the x squared, which is an invisible 1, right? There's a 1 here. My b is 8, the number in front of the x, and my c is -9. And to decide if it's up or down, I look at a, and since a is positive, we're going to say it opens up. Anytime it opens up, you immediately follow that with the word minimum. Axis of symmetry, vertex, extreme. What are the other questions? X-intercepts, Y-intercept, domain, range, and graph. Okay, so I'm pretty sure this is the order that the questions are going to be in. So up or down, min or max. Next, what I would fill out right now, honestly, I would fill out my domain. Your domain is all real numbers. Okay, the domain is always all real numbers, every single time. We can also start filling out the range. If it opens up, my range is going to be greater than or equal to something. I don't know what the something is yet, but I know it'll be greater than or equal to it. The other thing I can fill out right now, I know my y-intercept right now. Because in standard form, the y-intercept is the letter C. The y-intercept is a dot, it's a point, so I'm going to put 0, -9 for my y-intercept. So I already know it's going to definitely cross at -9. This is all the information that I can fill out just by looking at the equation. So notice I've not done any actual math yet. All I've done is looked at the equation. I looked at my positive A, and I looked at my my C value for my y-intercept. Okay, so now we're going to do some work. So one of the equations that you're going to want to have memorized for tomorrow is to find the axis of symmetry in standard form is x equals -b over 2a. So x equals -8 over 2 times 1. Now on your test tomorrow for the axis of symmetry, it's going to say write the equation of the axis of symmetry. So an equation is anything that has an equal sign. And so x equals -4 is considered an equation. It's not a super complicated equation, and that's okay. It's got an equal sign, we're good. Okay, so this is the axis of symmetry. Please do not write this work on the answer line. Please do not write this formula on the answer line. We want the x equals a number. As soon as you know your axis of symmetry, you can also put that number as the first number of the vertex. The axis of symmetry is the same as the x-coordinate for your vertex. You also can start graphing if you want to. You can graph your axis of symmetry. This is a vertical line. It's invisible, so we usually draw it as a dotted line. And it's just kind of telling us where the center of the parabola is going to be. Now that we know the axis of symmetry, we're going to take the number that we found, the -4, and we're going to plug it into the x's of the original problem. And then we'll solve for the y value of the vertex. So it's y equals x squared plus 8 times x minus 9. And you can, if you write this out accurately, where you are surrounding the x number with parentheses, and then everything else goes out on the outside of the parentheses, you can just type this into your calculator exactly how I have it written out. Extra credit quiz is in the quiz category, not on the test category. If you don't have a calculator, I don't have my calculator with me, so I'm going to try to do this by hand. So this is 16 minus 32 minus 9. I don't know if I did that right. Can you guys confirm if I did that right? I don't have my calculator. 32 minus 9. 7. Yeah, that's what I thought it was supposed to be. What did I do wrong? Did I write it down wrong? So where's 32? It's a negative x squared, isn't it? I'll have my glasses on. Jim, is it a negative x squared in the original problem? Yeah. You should have stopped me. I wrote so many things wrong. We're going to go back and fix this because that's supposed to be a negative x squared, which means my a is negative 1. Did anybody try to stop me? No. Which means my a is negative 1, which changes a whole bunch of stuff, guys. A whole bunch of stuff. Changes that. It changes my range down here. It's going to change my axis of symmetry. It's going to change all this stuff that I just did. Actually, let's just delete all that. Let's see what we can get rid of. All right, let's try this again. I apologize. I do not have my glasses on, and the screen is very small. Okay, so now that a is negative 1, that makes this a negative 1 down here. So that is negative 8 divided by negative 2, and that is positive 4. So this was supposed to be a positive 4. Also, now that a is negative, it is it's a down parabola, which has a max, and my range is going to be a less than or equal to. I'm trying to fix everything in red that I had wrong. I apologize. Megan, it's quadratic formula. Quadratic formula. Good job, Jonathan. Okay, let's keep going. I think I fixed everything now. So this will change what we were doing. Okay, so this one is tricky. So it's y equals, and then there was a negative sign, and then there was the letter x. So it's super important, especially when the negative sign is part of the original equation, that you put it on its own, and then you write a parentheses and you plug in your x. Especially if you're going to be using a calculator, if you're just going to be typing this into your calculator, it's really important that you write it out correctly. The range is determined by if it's up or down. If it's up, your range will be a greater than or equal to, and if it's down, it's a less than or equal to. How do you plug it into what? When you're done with the quadratic formula, you just write it as an ordered pair. Blah, 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 comma 0. Yeah, that's right. It's going to look really funky and weird, but that's just what it looks like. Okay, this is so much better. 7. There's that 7 we were looking for. Okay, so 7 for the vertex. 7 is also the extreme value. And 7 is the number you're going to put on your range answer. So please notice I wrote those 3 blue 7s. Those all came from the same place. Okay, so once you know your vertex number, you can also write down your extreme number. You can also write down your range number. They all are the same number. Let me put my axis of symmetry back on there. I have a feeling this graph is not going to be big enough. I feel like this was the last one on the long paper homework, number 8. And on that one, it won't fit on the graph, so you can either graph it on a different paper or you can count by 2s. You can count by 2s if it won't fit on the paper. On your test tomorrow, everything will fit in the size graph that we give you. So on the test, if you are finding your vertex and your vertex does not fit on the graph, you get like 2, -11, then you got the wrong vertex. On a test, we will make sure that everything fits on the size graph that was given to you. All right, before I find my x-intercepts, I am going to graph. That's the only thing that we're missing over here is the x-intercepts. So I'm going to graph my vertex, which is at 4, 7, 4, 1, 2, 3, 4, 5, 6, 7. And on standard form, yes. On standard form, you can take your axis of symmetry, plug it back in, and that'll give you your y. Y-intercept on standard form is just the letter C. Or you can look at the graph when you're done graphing. And your y-intercept is always a ordered pair, 0, a number. All right. So, oh, hun, I just said it. In standard form, it's C. Or you can look at your graph. So when I'm done graphing, we can look at the graph. I'm hoping we learned our special ordered pairs. 1, 1, 2, 4, 3, 9. Yes, you can find the vertex from standard form. I just did that. You need to find your axis of symmetry using this formula up here, and then you plug that in. Oh, it will, because it's -9. It's not going to be with the first 3 special ordered pairs. Let's, if we do the first 3 special ordered pairs, and we have to multiply the special ordered pairs by -1. Sorry. And so they're all going to turn into negatives. So we're going to start on the vertex, and we're going to go right 1 and down 1. And we're going to reflect. We're going to go right 2 and down 4. And we're going to reflect. We're going to go right 3 and down 9. 5, 6, 7, 8, 9. And reflect. Now, at this point in time, we cannot see the y-intercept. However, these special ordered pairs, 1, 1, 2, 4, 3, 9, they don't stop at 3, 9. It's just that like 3, 9 is usually the last one we can fit. We can actually go further. The next one would be 4, and 4 squared is 16. And if I do that one, over 4 and down 16, 9, 10, 11, 12, 13, 14, 15, 16, and reflect, there is my y-intercept. So sometimes you just got to do a little bit more than the minimum requirement. So you can get the y-intercept from the graph. On this one, you would just need to make your special ordered pairs keep going. And then redraw a U-shape. Guys, it has to be a U-shape. It can't be a V-shape. I apologize. Mine is definitely not a U-shape, but we're going to pretend like I am drawing nicely on a piece of paper. Yeah, actually, this one is a perfect example for that. If you look at my graph, the x-axis is right here, and I did not draw dots on the x-axis, but my graph goes through the x-axis. My graph goes through the x-axis somewhere between 1 and 2, and somewhere between whatever these numbers are. 1, 2, 3, 4, 5, 6, and 7. So this is a perfect example of finding x-intercepts that have a radical answer. Your x's will be on the graph. If it's in standard form, you can always just do quadratic formula, which I'm going to show you how to do right now. No, it's the same. You can plug in zeros for x and y intercepts. Just make the other letter a zero. So if you're looking for the y-intercept, make the x a zero. And if you want to find the x-intercept, make the y a zero. All right, quadratic formula. So again, my parabola is crossing the x-axis, but it's not crossing on nice whole numbers. So I'm going to have to do quadratic formula for this one. It's mandatory. We can't avoid it. And so quadratic formula you'll want to have memorized from last chapter. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And, we get our a and our b and our c from the original problem. I would need to look it up, hon. I don't have the extra credit quiz open right now. All right. X equals negative 8 plus or minus the square root of 8 squared minus 4 times negative 1 times negative 9, all divided by 2 times negative 1. It's negative 8 plus or minus 64 minus, is this one from the quiz? It is? Oh, this is problem 1 from the quiz, guys. Minus 36, all divided by negative 2. It's extra credit. It's not supposed to be easy. All right, at this point in time, so a lot of my students forgot, at this point in time, you're supposed to take the 28 and do a factor tree. You're looking for those perfect squares. And so the square root of 28 changes to the square root of 2 rad 7. Make sure the 2 is right next to the square root. Make sure that it's not all the way over by the 8. It doesn't get to hop over the plus or minus sign. Okay, next we have 3 outside numbers, 3 numbers that are not underneath a radical sign. We have a negative 8, a 2, and a negative 2. Since all 3, I would say probably not. No partial credit for decimals. You just need to do a factor tree and you're looking for pairs. If you find a pair of numbers, write that number on the outside. Anything that doesn't have a pair stays on the inside. The negative 8, the 2, and the negative 2, since all 3 of those can be divided by the bottom negative 2, I'm going to divide everything by negative 2. So I'm going to divide the negative 8 by negative 2, which creates a 4. I'm going to divide this 2 by negative 2, which makes a negative 1. And then this negative 2 just completely goes away. Now, I don't know. I would accept this answer on a test. I'm not sure if the other teachers would. The way that I had written it on the answer key, I had not written the negative 1, because the negative 1, what it does is it takes the plus sign from the plus or minus, and it makes it a minus sign, and then it takes the minus sign and it makes it a plus sign. And that's still a plus or minus symbol. So like the negative 1's not really required. And then again, because somebody was asking, how do I write this? You write it out, 4 plus or minus rad 7, and then you just put comma 0. And you write it as an ordered pair because we're doing graphs this chapter. So when we do graphs, we have to make sure that our intercepts are their dots on a graph, so we have to write them as ordered pairs. All right, that was like the first question you guys asked. Let's do a vertex form one. Okay, so I'm going to clear my screen. Do you guys have a preference on a vertex one that you want to see? Or somebody wanted some from the quiz. Which ones did we want from the quiz? Okay, I just did number one from the quiz. That was the one you asked. That was what we just did right now. I'm seeing 5. Is 5 a good one? 5. Yeah, we can do 5. Okay. Yes, there will. That was that was number one on the quiz that some teachers gave out, and absolutely there will be one like that on the test tomorrow. Different numbers, obviously, but same concepts. Okay, so number 5 from the quiz. So this one is in vertex form, and the reason why I know it's in vertex form is it's got parentheses in it. That's like a dead giveaway that it's vertex form. Now this one is missing something. So vertex form, oops. Vertex form is y equals a, x minus h squared plus k. So this one is missing, it has the parentheses part, but it's missing the number that's to the right of the parentheses. So if you feel more comfortable, you could put a +0 on the outside if that helps you. Okay? And on these problems, we have an a, which is the very first number, just like on standard form. And then we have an h, and the h is the opposite of whatever's inside the parentheses. Because if you look at the original problem, it was being subtracted. So if it says +1, your h is actually -1. And then the k is whatever is at the end of the problem. And since there was nothing at the end of the problem in this question, the k is 0. All right, we've got our 9 questions and our graph. So question number 1 is, yes, you have to switch the sign. When you're plugging it in, you should plug it in as a minus sign. X minus whatever number you get. So if that number is positive, then you would do X minus that positive number and it would change into a minus. Or if it's a plus, I'm sorry, if it's a negative number, you would do X minus that negative number and it would change to a plus. All right, so first question, up or down? And just like on our standard form, we're going to look at our A, which is a positive. I think this time it's positive. So we're going to write up. Up is always automatically followed by min, and up will determine the direction of my inequality for my range. So I'm going to start that down here. My range is y is greater than or equal to. Okay, all of that, those 3, they're not full. The last one's not a full answer, but the 2.5 answers. 2.5 answers I got from the knowledge that A was positive. Also, right now I can write my domain because that is all real numbers every single time. All right. In this problem, you want to do your vertex first and your axis of symmetry second. So the vertex, again, is the opposite of the number in the parentheses, which we said would be -1, and then the number to the right of the parentheses, which would be 0. So my vertex is negative 1 comma 0. The first number of the vertex also is part of the axis of symmetry. So it's x equals negative 1. The second number from the vertex is your extreme value, and it's the number that gets written in the range. So all of these numbers get used multiple times. I'm going to graph before I say my x and y intercepts. So for my graph, my axis of symmetry is at negative 1. Oh my goodness, that was a horrible start. Okay, and now I'm going to graph my vertex. My vertex is at negative 1, 0. So negative 1, 0. And guys, I just put a dot on the x-axis. That means I'm ready to write my x-intercepts. My x-intercept is negative 1 comma 0. As soon as you put a dot on the x-axis, or 2 dots on the x-axis, you are ready to write your intercepts. Okay, so my x-intercept is negative 1, 0. Okay, I'm not ready for my y-intercept yet. I have not drawn anything on the y-axis. So I'm going to go to my special ordered pairs. 1, 1, 2, 4, 3, 9. In this problem, my a is 2, so I will be multiplying all of these numbers by 2, which changes it to 1, 2, 2, 8, and 3, 18. These numbers down here are the ones I'll be using. And again, the most important thing about your special ordered pairs is that you always put your pencil on the vertex to find them. So pencil on the vertex, I'm going to go over 1 and up 2. Oh my gosh, guys, I just found the y-intercept. It's right here. It's at 0, 2. And I'm going to keep graphing. So I'm going to put my pencil back down on the vertex. I'm going to go over 2 and up 8 this time. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to reflect. I definitely will not be able to fit 3, 18, so I'm just going to stop there. However many you can fit is how many you should do. Oops. And that's it. We're done. That's the whole problem. Okay. Since we're on the quiz, let's take a look at number 4 from the quiz because I saw that you guys wanted that as well. The special ordered pair points, the like dots on the graph. Do you understand the chart that I drew? Who is your teacher? Are you my Gavin or are you somebody else's Gavin? Strong. Strong does this. You have special ordered pairs that you want to memorize. I'll rewrite them. That's okay. I just wanted to make sure because there's for sure one teacher who teaches it differently, and I wanted to make sure that it wasn't that you didn't have that teacher, because then I would switch gears and we would be doing something different right now. That's fine. Okay. So your special ordered pairs, basically you start with the numbers 1, 2, and 3 for your x. And since all of these problems will have an x squared in them, you square those numbers to get your y. So 1 squared is 1, 2 squared is 4, 3 squared is 9. And this would be the size of a normal parabola. Sometimes, though, our parabolas change shape, and they change shape based on the letter A. So when A is 1, it's going to be a normal size. But if A gets bigger, then it's going to get skinnier. And if A gets smaller, it's going to get wider. And if A is negative, it's going to flip upside down. So A changes the size and the shape of the parabola. And the way it does that is it takes all of your y coordinates and it multiplies them by whatever your A is. So our special order pairs are not actually 1, 1, 2, 4, 3, 9. They're 1, 1A, 2, 4A, and 3, 9A. What the heck? Okay. And so in the problem we were just doing, our A was 2. So what I did was I multiplied all of my y numbers by 2. Yeah, you multiply by A. And so then you get a new value. The 1, 2, 3 stay the same always, but my y values are now 1 times 2, which is 2, 4 times 2, which is 8, and 9 times 2, which is 18. So your y values are the only numbers that will change. The 1, 2, 3 will not change. The 1, 4, 9 will change. And then these are directions on where to go from your vertex. So you put your pencil on the vertex, and you go over 1 and up 2. And you go the other direction also, over 1 and up 2. Then you put your pencil back on the vertex and you go over 2. Oops, I went too far. Over 2 and up 8. Over 2 and up 8. And if you could fit 318, I would say graph that one also. I hope that helped. You're welcome. Okay, we're looking at number 4 on the quiz now, which was y equals negative x plus 3 squared minus 3. Okay, so first we start by looking at the letter A, which is a negative 1. So negative is down, max, and y is less than or equal to. All of that information I get from the fact that A is a negative number. I don't even care what negative number it is. All I care is A is negative, down, max, less than or equal to for my range. Okay, I can also write my domain right now. It's all real numbers. All right. For my axis of symmetry, it's going to be x equals something. My vertex is going to be an ordered pair, so I'm just going to kind of set those up right now because someone said earlier it's hard to talk about this one because of the double negative 3. So I'm going to try to color coordinate. So this plus 3 inside the parentheses, the inside one changes signs. So that will change to a negative 3. And that's the x value because it was in the parentheses with the x. And when you find your x value, you also put that for your axis of symmetry. This minus 3 that's at the right side of the parentheses, that is your y value. And we don't change the sign of that because it was originally a plus sign up here. The y value gets written in the vertex. It gets written as your extreme, and it gets written as your range. All right. Next, I'm going to graph. Sure, yeah. Negative 3. So over here. Okay, so negative 3 is right here. My special ordered pairs, 1, 1, 2, 4, 3, 9, and then I've got to multiply them all by -1. In this problem, that's just going to make them 1, -1, 2, -4, 3, -9. So all it does is it ensures that you go down instead of up. Okay, so I'm going to go right 1 and down 1, left 1 and down 1. Pencil back on the vertex, right 2 and down 4. 1, 2, 3, 4. Left 2, down 4. Now I can't fit 3, 9 on here, so I will not be graphing that for this problem. And I get this. So now my two empty answer lines are the x-intercept and the y-intercept. So looking at this graph, my parabola starts here and it goes down forever. But my x-axis is up here. So my parabola does not touch the x-axis, and it also never will. It's moving away from the x-axis. And so for this problem, we will say that there are no x-intercepts, or you can just say the word none for the x-intercepts. Make sure that you don't write the number 0. The number 0 implies that it crossed on the number 0. Yeah, we can definitely do that one, Hayden. Sorry. My nose is so congested from these winds. It's horrible. All right. And then we need the y-intercept. Now, there will never be no y-intercepts. There is always a y-intercept. Like these problems always have a y-intercept. There's always only one of them. So you could even preload that answer line with a 0 comma. There's going to be a number there. Now, I can't see it on the graph, but that's just because the graph wasn't big enough. Had I have been able to fit 3, 9, I would have been on my y-axis. So one thing you can do is you can pretend to like go right 3 and down 9 and see where that would land you. Or the y-intercept is really easy to calculate. You just make the letter x into the number 0 and it will calculate it for you. And you can just type this whole thing into your calculator. I don't have a calculator, so I will be doing this by hand. You do need to square the 3 first and keep the negative sign that was in front. So my y-intercept is -12. I know I heard so many people talking about they have a chem test and a math test tomorrow. I feel really bad for you guys. I'm sorry that those landed on the same day. I do think, though, I don't think the math test will be overwhelming. So those of you, I know Mr. Strong gave out the quiz. I gave out the quiz. I'm not sure about the other teachers just because I didn't ask them. But tomorrow's test should be about the same length as the quiz. So I feel like hopefully it should not be too overwhelming. All right, guys, we finished this problem. We'll go back. We'll do number 2 and 3 from the quiz. And then I think our time's going to be up. We might even run a little bit over. But I know you guys wanted one. Yeah, standard to vertex is number 3 from the quiz, so I will definitely do that. Somebody else wanted number 2, and I've already got the graph up here, so I'm going to do that first since I have to stay on here, and then we'll switch to just a blank screen to do the standard to vertex. I thought I trapped all of that writing, and I did not. I'm going to leave this there. Okay, so number 2 is y equals 2x squared plus 4x minus 6. So this one's in standard form because like there's no parentheses. So I have an A, I have a B, and I have a C. And I'm going to look at my letter A, which is a positive number. So I'm going to write up, I'm going to write min, I'm going to write y is greater than or equal to. I'm going to write my domain, which I never should have erased because it's just the same thing on every problem. Guys, if you miss domain tomorrow, oh my gosh, you're going to make your teacher so sad. Don't miss the domain. It's the easiest thing, okay? I can also write my y-intercept right now. My y-intercept is 0, comma, my c value. All right, I think that's all I can write without doing any math. So let's start doing some algebra, some math. My formula, so on this one we're starting with the axis of symmetry, which is x equals a number, and the formula, so not the equation, the formula is negative b over 2a. So negative 4 over 2 times 2. And that's negative 1. So my axis of symmetry is negative 1. I can also write that as my x-coordinate on my vertex. Next, we will take the negative 1 and we will put it into these x's. So that's 2 times negative 1 squared plus 4 times negative 1 minus 6. And again, you can just type this into your calculator exactly how I have it written. And if you type it in exactly how it's written, you should get the right answer. Now, if you wrote it a different way, you might not get the right answer. So make sure that you're surrounding your negative numbers with parentheses and that everything else is going on the outside, particularly the square has to go on the outside. Sorry, guys. All right. Negative 8 is my y value, so that goes in my vertex. It is my extreme, and it's also part of my range. So the only thing we have left is the x-intercepts. If you are in love with the quadratic formula and you want to do the quadratic formula to find your x-intercepts, that's fine. More power to you. Or graph it and just look to see where it is across the x-axis. So that's what I'm going to do. I'm going to graph it, and I'm going to go back. I can never get that first line right. I'm going to go back and find them later. So my vertex is at negative what? Yeah, negative 1, negative 8. 1, 2, 3, 4, 5, 6, 7. It's all the way down here. My special ordered pairs, I will need to alter because my A is 2. So the first one will turn into 1, 2. The second one will turn into 2, 8. And the third one will turn into 3, 18. I don't understand your question. Oh, the question number 5. Got it. Okay, thank you for clarifying. That is called the extreme value. And the extreme value is just the y-coordinate from the vertex. Sorry, I forgot to write the words next to them this time. Are there any other? So question 1 was, does it open up or down? Question 2 is, does it have a min or max? Question 3 is the axis of symmetry. Question 4 is the vertex. Question 5 is the extreme. Question 6 is the x-intercepts, which we have not found yet. Question 7 is the y-intercept. 8 is the domain, and 9 is the range. Yeah, I should have written down the words again, but we had already done it like 3 times, so I got a little lazy. I apologize for that. All right, so I'm going to use these new ordered pairs to graph. So I'm going to put my pencil on my vertex. I'm going to go right one and up two. I'm going to go left one and up two. Guys, we just drew a dot on the y-axis. We should probably check and make sure it's in the right spot. We think it's supposed to be at -6. So let's check 1, 2, 3, 4, 5, 6. We did a good job. It is at -6, exactly where we thought it would be. Okay, next I'm going to put my pencil back down on the vertex. I'm going to go right 2 and up 8. And I'm going to go left 2 and up 8. And we just put some dots on the x-axis. That means I am ready to write my x-intercepts. So if you actually draw dots on the x-axis, then you can just write those ordered pairs as your x-intercepts. So I'm going to do this one first. That is the ordered pair 1, 0. And now I'm going to do this one, which is the ordered pair -3, 0. They are good numbers, so that means we don't have to do quadratic formula, which is really nice. It's kind of fun when we don't have to do quadratic formula. All right. And then, you know, on your quiz, I think you could fit 318. I don't think I can fit it on mine. I think it's like one past where I'm supposed to go. I think it's like right here. But I think on the quiz it fit. It was like at the very tippy top. And then, you know, you do your best to draw a U shape. Just make sure it's not a V shape, guys. And make sure you're touching all the dots, which you know, it's hard to draw on a computer. But, oh my goodness. When you're taking your test tomorrow, do your best to draw a U and touch all the dots. It doesn't have to be perfect, but it should not be a V shape. It should not have any like pointed parts on it. All right, that was number 2 from the quiz. No, I cannot do the quadratic formula really fast, and somebody else wants to see something else. So I'm going to do that first. We did quadratic formula earlier. If you want to go back and rewatch the beginning of the recording after we post it up, there will be a quadratic formula one up there. Let me do the changing standard to vertex first, because a couple people have been asking for that. All right, so it was oh, see, I wish I had. Do you guys know how to raise your hand on the, like in the thing? Can you do me a favor and raise your hand if you have Mr. Strong as a teacher? Any students that are currently listening, if you have Mr. Strong, can you raise your hand? Okay, you can unraise your hand. So Mr. Strong teaches this differently from how I teach it. So I will show you both ways. And I think, who wanted this one? I think Mr. Strong's student wanted this one. So I'm going to do this the way that Mr. Strong does it first. And then I'll go back and do it the way that I taught it. Just to make sure that we're covering all of our bases. So the way that Mr. Strong teaches it, you do y equals, and from these two terms, you're going to factor out the -2. So it will become x squared, and we're dividing by -2. So -2 divided by -2 is 1. And then -8 divided by -2 is +4. And then you're going to put a blank spot. And then this -15, he stays outside. And if you've got a blank spot in here, you need a blank spot out here also. Those will cancel each other out. All right, we're going to take half the middle number, which is 2, and we're going to square that, and that goes here. And then, so we just like pulled out of thin air. We randomly put a 4 here. And this 4 is being multiplied with that -2. So in reality, with these two things together, I just put a -8 on this side of the problem. Just randomly out of thin air, pulled a -8. If I put a -8 randomly over here, I can't just like put that in there and be like, ooh, look, now there's a -8. So I need something to cancel out that -8. So the thing that cancels out a -8 is a +8. So I'm going to add an 8 out here. Because I have this random -8, I need to put something in to counteract that random -8. So I'm going to put a +8. Okay, so now we have y equals -2. This whole parentheses here, this is a perfect square trinomial. And if I factored it, it would turn into x plus 2 times x plus 2, otherwise known as x plus 2 squared. And then we need to combine together these two things. -15 plus 8 is -7. And this is vertex form. You're welcome. Good luck tomorrow. Does anybody need to see this done using a different method, or are we good? So I know if you're my student, I taught you to move the 15 over here, so we did it a little bit differently, and I can do it that way if you're willing to stay up for a couple more minutes. But if everyone's going to sign off, I'm down for that too. Yeah, absolutely. Let me get a new screen. You're welcome, hon. Good luck tomorrow. All right, so the way that I taught my students, and I think Miss Lindahl might have done it this way as well. I'm not sure about Mr. Pixler or Mr. Ford. But we added the 15 to the other side. That's a 15. And then we factored out our A, and when we factored out our A, that's when we put in our blank spaces. So now I'm going to put a blank. I'm going to factor out just the -2, so I'm not factoring out a GCF, just factoring out the number in front of the x squared. And just like on the previous problem, that means I'm dividing this by -2. So this will become 1x squared plus 4x. And then when I put in this blank, I want it to be inside the parentheses. I want it to be inside the parentheses. Okay, so now I'm going to look in at this parentheses. I'm going to take half the middle number, and then I'm going to put that in a parentheses squared. Then I'm going to take this 2, and I'm going to square it. Finally, I'm going to take the 4, I'm going to hop out and times it by the -2, and I'm going to put a -8. Okay, so this is the problem where you like skip around a lot. You don't go in like a nice linear order. It hops and jumps around. Okay, so this whole parentheses, it turned into this thing. I'm going to write it down here so it looks cleaner. X plus 2 squared. That's what all of this turned into, including your plus a blank spot. Your plus a blank spot will no longer be on the left-hand side. I'm going to bring down my -2 that was in front. Over here, I'm going to combine together 15 minus 8 is 7. And then as a final step, I'm going to subtract the 7. So the number one mistake I've seen my students make with these problems is they try to condense it into less steps. It's already like not even that many steps. It's like 1, 2, 3, 4, 5 steps. It's not that big a problem, but people try to do it in like 2 steps, and then they make all kinds of mistakes. So please just make sure that you are that you're writing down all of the steps. You want to make sure that your blank spot is inside your parentheses. Hey, Sean, go see if Grant fell asleep or not, please. And that it doesn't carry down to the next step. To the next step, you should only carry down your parentheses squared and your letter A. So there really shouldn't be anything right here until you move this number to the other side. All right, there's only 3 of you left. I hope we're good now. Good luck on your test tomorrow. And I think that's it. You're welcome. You're welcome.